Alright, what is the IUPAC name of the following? I'm going to sketch the skeletal and I'm going to name it. And then I'll redraw that condensed structure and we're going to name it as well. And got a double bond right there. Now my H looks like crap, so I'm going to redraw that. Alright, our first goal is always to find the backbone, the longest continuous chain, and since there's a double bond in this one, I know it must be part of the backbone. Alright, and then over here I'd only go down because that's longer. On this other side I got an interesting little conundrum. I can go up here and get 2 carbons, or I can go here and get 2 carbons. Both ways I get 2 carbons. Now I'm going to do it both ways and name it, because it is 2 different names if you do it this way. And then I'm going to tell you about a little known rule that tells us one of these is correct and the other one is not. I'll just go over here. Alright, so on the left I have a substituent off of my double bond. Now, if we look at this, we are going to number it so the number that's close to that double bond has the lowest possible number. So I am going to start over here because it gets the double bond starting at the 2 position. Had I started down at that location, I would go 1, 2, 3 before I get to the double bond. So it makes more sense to go this way. All right. And my circled substituent up there, if we back up, we'll see that when I had the 3 carbons in a row linked in the middle, that is an isopropyl group. Alright, so putting the full name together for this one, our backbone curls down, and remember, I'll put this over here in red as a reminder. When I have a double bond, and the 2 guys over here are different, I'll do H's and carbons, and over here they're also different, and I'll do H's and carbons that way. We have what we call a stereoisomer. What makes it a stereoisomer is that double bond doesn't rotate. And since it can't rotate, if I swap one of these sides, I have a different molecule. Now it only applies right now for us to the actual carbon chains, but the neat thing is if the carbons are both up or both down, technically on the same side, you have what we call cis stereoisomer. And the other one, the zigzag, where one is up is one down, is trans. So this guy that we did over here right now is cis. So my full name, I'm going to have the cis, and then in the 3rd location I have an isopropyl, and then I have 2 pentene. The 2 is telling us where the double bond starts. Alright, now technically we haven't broke any rules from what I taught you in class and what was introduced in the textbook. On the right though, because I moved the backbone, I still have just 5 carbons, but now I have 2 substituents. That one is a methyl, and this one is an ethyl. Now you might be thinking, if you've been practicing these, that you'll go with the one on the right because methyl and ethyl are substituents you probably already learned. And I'll go ahead and tip you off and tell you that's a good strategy. I'll explain why in a moment, but let's finish naming this. Alright, so when we do the backbone, we're still going to go 1 and 2, 3, 4, 5. We are going to still go from the left because we get to the double bond at the 2 position. Alright, now we're ready to put together. Now since I changed the backbone, my backbone has now got the backbone is going up and then down. So we have a trans conformation now. So trans comes first, and then we're going to put our substituents in alphabetically. So 3 ethyl, 4 methyl, and then the 2 pentene. Alright, now, technically speaking, this one is the only one that's correct. And the reason it is correct, we have a weird rule that we don't really cover this early on into nomenclature that basically says if you have a choice of two pathways, like we did here, where our backbone is 5 carbons, if one of them gives you more substituents, so more groups that we're circling, that's the correct one. Because what it does is we sometimes get branches like this. We call this a complex substituent in the sense that it's not nice and straight like these are. It's got a bend in it. It's got the two things like that. So that complex substituent we want to avoid. So if we get more substituents, we typically avoid those complex substituents.